Alright guys, this is the first video of the holiday break packet. And we're talking about half-life and double life. And what these things are really just fancy words that indicate exactly what will go inside the parentheses in our exponential growth and exponential decay formula, right? So we have our formula here, A equals P times 1 plus or minus R and now over N to the T times N power. So in these problems, we're not going to be compounding interest. We're not going to be talking about money. We're just going to be talking about growth of a substance or decay of a substance. So you'll hear growth and decay a lot in like chemistry when you're talking about a population, things like that. So in these problems, N is probably going to be 1 almost all the time. And in the ones we'll do today, it is all the time equal to 1. So it's really just like using that formula that we used to use back when we started doing exponential growth and decay. So A says we have a bacteria culture that's doubling every 4 hours, and we're going to start with 10,000 bacteria. And we want to find the number of bacteria in the culture after 30 hours. So this is just like back when we started, A equals P times, and we said that N is going to be 1, so we don't even need to write divided by N or T times N because N is 1 in this case. We know that we initially have 10,000 bacteria, but that's all really that's obvious to us at this point because there's a little bit more thought that needs to go into this. It doesn't tell us a rate, it's just saying that the bacteria culture doubles. So if something's doubling, that means you have the one thing and you're going to double it. You're going to add 100%, right? This is a 100% increase. So if you take 100% and turn it into a decimal, that's a 1. So what goes inside your parentheses is 1 plus 1, or when we get to our next step, we're just going to end up replacing it with a 2. So if the culture is doubling, all that goes inside your parentheses there is a 2 because 1 plus 100%, or 1 plus 1, is 2. Now we have to figure out the time. Well, it's going to be 30 hours later, but we know that our culture only doubles every 4 hours. So it's going to double in 4 hours, and then it's going to double again in 8 hours, and it's going to double in 12 hours, and it's going to keep going like that until we've hit 30 hours. So it's not going to double every hour. Our time can't just be 30. We have to divide it by 4 to indicate that we're accounting for the population doubling only every 4 of those 30 hours. So now that our equation is set up, at this point, we can just throw that into a calculator, and we will get 1,810,193 bacteria. And we do get some extra, but remember, you can't have half of a bacteria, so we have to leave it as a whole number, and we have to round down, regardless of point what is left over after that. So if we're talking about doubling, then our formula is going to be A equals P times 2 to the T power. All right, so doubling, you're going to have a 2 there. Let's move on to the next one. If the world population triples every 50 years. Okay, so when it was doubling, we put a 2 inside the parentheses. If it's tripling, we're going to put a 3 inside the parentheses. And it happens every 50 years. In 1980, the population was 4.5 billion. Assuming the pattern continues steadily, estimate the population in the year 2180. So first, we got to figure out how much time has passed. Well, from 2180 to 1980 is a total time of 200 years. But it's only doubling every 50 of those 200 years. So we're going to divide that 200 by 50. So what we'll end up throwing into the calculator or into Desmos, whatever you're using, is just 4.5, which stands for people in billions, times 3 to the 4th power. 200 divided by 50 is 4. And when you evaluate that, you'll get 364.5 billion people. Now in this case, you can leave that decimal 0.5 because it's not talking about 364.5 people, it's 364.5 billion people. So what this really means is 364 billion 500 million people. So if you want to write it out like that, you can. But what this is just shorthand for this. So you can have that decimal there because it stands for 500 million people, basically, not 0.5 of a person. So what we learned in that problem is that if you have the word triples, your formula now is A equals P times 3 to whatever your time is. All right, so you guys are getting the picture here. What happens if we've got iodine, which has a half-life of 8 days? Okay, so iodine 131 is some substance that we don't need to know really anything about. But it's going to ask us what fraction of the original sample would remain at the end of 32 days. So let's assume that at the beginning we have all of our sample, 100% of the sample. Now it has a half-life, which means it's decreasing by 50%. And 50% as a decimal is going to be 0.5. So what goes inside our parentheses is going to be 1 minus 0.5, which is 0.5. So when we're talking about half-life, it's very easy. You could just remember that if it's half-life, 1/2 is what goes on the inside of the parentheses, because 1/2 is the same as 0.5. Now what about our exponent? Well, 32 days are passing, but it only has its half-life every 8 days, so we have to divide that 32 by 8. So in total, we're going to get 1/2 to the 4th. We just have to throw that into a calculator, and we get 6.25. Now remember, that's a percent. So if we started off with 100% of our substance, now we have 6.25% of our substance. This question said, what fraction of the original sample? So a percent is a number out of 100, which means that 6.25% is the same as 6.25 out of 100. Now that would be a fraction, although I don't like leaving a decimal in the numerator. So what we'll do here is we'll just swing this 2 places that way and move this 2 places that way, and we'll leave it as 625 out of 10,000. That's an appropriate fraction to model the percentage that we got as an answer. All right? So the lesson to be learned here is that if we're talking about a half-life, that's going to be this formula with a 1/2 inside the parentheses. The key to these problems is just reading and identifying the key word that's telling you what to put inside the parentheses, because the rate is changing what's inside the parentheses, and you could just, if you see the word doubles, you could put a 2 in there. If you see a word triples, put a 3 in there. Half-life, put a 1/2 in there. All right? So you've got some homework problems to do on your own based on that. Good luck.